All right, so now finishing up 6.1. So we got to these first three already. Now we're going to finish up with this one. So we want to figure out what the measure of each exterior angle in a regular polygon is. So let's look at that. So for a regular n-gon, which is just a regular polygon, doesn't matter what number of sides it has, or each exterior angle is going to be given by 360 divided by n. Okay, so again, this formula will not work for any polygon. It has to be a regular polygon, all sides the same, all angles the same. But if we have a regular polygon, we want to figure out what one exterior angle is, then we're going to use this formula, 360 divided by n. So let's look up here. What is the measure of each exterior angle of a regular nonagon? Again, always pay attention to what it's asking you. It's asking for each exterior angle in a regular nonagon. Okay, so that fits all of our criteria. So nonagon means 9 sides, so n is going to equal 9. So my formula is 360 divided by n, so I'm going to plug in n equals 9, so I get 360 divided by 9, and I'm going to wind up with 40 degrees. So each exterior angle in a regular nonagon will have a measure of 40 degrees. Okay, so that's these 4 angle measures. So now let's just look a little bit deeper. So we're going to talk about just have a little, fill it out a little chart right here. Just some basic ones that we're going to see a whole lot. Okay, so in this one, so we're going to put interior angles in this left column, and then we're going to put the sum of them in the other column. Okay, so right off the bat, we've got in a triangle, n is going to equal 3. So if we plug it into our one interior angle formula, which that formula is 180 times n minus 2 over n. So we plug n equals 3 into this formula, we're going to get 60. Okay, and if we want to figure out what the sum of all those are going to equal, again, this is assuming that all of these are regular polygons. So we want to figure out what the sum of each of these interior angles are. We're going to plug it into this formula, 180 times n minus 2. So 180 times 3 minus 2 will give me 180. Okay, so then we go through filling the rest of the chart. So for 4-sided figure, each interior angle will have a degree of 90. The sum of them will always be 360. Okay, so over here it has to be regular polygons. Over here it doesn't really matter. Okay, for pentagon, each interior angle is 108. The sum of them will be 540. Each hexagon will be 120. Multiply that by 6, and we get 720. Heptagon, each one will be 128.6 degrees. We're rounding that one off. It's okay to get a decimal answer every now and then. And then it has 7 sides, so all of them will be 900. For octagon, it'll be 135 for each interior angle. And then for all of them combined, it'll be 1080. And then one other thing I want to mention is that what if we looked at the exterior angles? Okay, let's talk about the exterior angles. So again, if we're assuming that we have regular polygons, we would talk about the exterior angles. Well, keep in mind the formula here will be 360 divided by n. So in an exterior angle for a regular triangle, we'd get 360 divided by 3, which would be 120. For a 4-sided figure, 360 divided by 4, which would be 90. For a 5-sided, 360 divided by 5 will give me 72. 6-sided, 360 divided by 6 will give me 60. For a 7-sided, 360 divided by 7, which will kind of give me a decimal answer, but I can round it off to 51.4. For an 8-sided figure, 360 divided by 8 will give me 45. So let's compare these numbers now, okay? 120 to 60, 90 to 90, 72 to 108, 60 to 120, 51.4 to 128.6, 45 to 135. Okay, so if we look at kind of what's the relationship between those two numbers, you may notice that each pair of numbers is adding up to equal 180. And that's something that we can count on to be a fact, is that in each polygon, an interior angle plus an exterior angle will always equal 180. Well, why is that? Well, let's take this example of this triangle right here. Okay, so let me draw a triangle over here. Okay, so let's just say it doesn't matter if this is a regular triangle or not. Let's just say it is. Okay, so this is a regular triangle. Then this angle is going to be 60. That's the interior angle. So now if I want to figure out what is the exterior angle, I'm going to extend that bottom side. And this exterior angle right here that is created from this side of the triangle and this extension of that side, this will be 120 according to this formula. Well, now, if we forget about the rest of the triangle for a second and just look at this bottom side, well, these two angles, they create a linear pair. Remember, a linear pair from Unit 4 was two angles that basically sit on a straight line together, but they're separated by another ray. Okay, so this line right here, this side of the triangle, is separating these two angles. But if I was to take this line out of the equation, then these two would just be a straight angle or a straight line. And you could go through and do experiments with all of these and see that it's going to be the same for each other case, that one interior plus one exterior will always equal 180.